My name is Alex Breeze. I'm making this as the first video in a series of my attempts to solve P equals NP, or more to the point, showing people my failed attempts. Because while everyone else was working on projects that look good on a resume, I was busy trying to prove an impossible computer science problem. So, at least I have a few YouTube videos of various attempts, and maybe someone else will find these and find them interesting. So, quick notation. Specifically, when I was trying to solve P equals NP, I was trying to solve CNF or 3-SAT in polynomial time. So obviously CNF has clauses, so A or not B or C. This is an and. This should be a V, not an A. So or. Um, that's what a clause would be. And for the simplicity here, I'll just be writing A, B, C. So if you see something like A, B, C, this is a clause, A or B or C. So let's get into it. First attempt was fairly simple. Basically, you can think of 3-SAT as a multidimensional hypercube. So you have, say, A and not A, and then you have not B and B. And you can think of these as coordinates. So this is AB, this is not A, not B. And then you can throw in, say, C. So let's say this is not C, and this is C. So we have another block out here, and it connects in. And as we can see, as we add literals, we add dimensions to a hypercube. And a hypercube is actually a multidimensional cube. So it's like it's a term that has two things that describe itself, sort of like Sahara Desert. Anyways, the idea, generally speaking, obviously this is a hypercube, but I'll draw it out as like a two-dimensional area map. So just imagine a grid with all the possible solutions on it somehow. So the idea was, given a clause A, B, C, what this really says, or what it also says, is not A, and not B, and not C. Because if all these three are false, then the entire clause cannot be satisfied. So what we can think of it as is each clause blocks out 1/8 of the search space. 1/8 because it's 2 times 2 times 2 is 1/8. Well, 1 over 2 times 1 over 2 times 1 over 2. So we can essentially say that one clause blocks out 1/8 of the search space. And if you have another clause, that blocks out another eighth of the search space. But of course, the issue is that these clauses tend to overlap, so they don't each block out an eighth. And if you look at it, you can say the entire space has a size of 2 to the power of L, L being the number of literals. And each of these blocks out, well, 2 to the L minus 3, but each one blocks out less than the last because there's overlap, so there's less left to block out. So if you found the total area, then you could figure out if the entire search space has been blocked. And if it has, then it's unsatisfiable. And if it hasn't, then it is satisfiable. But we can probably see the problem is we have two clauses here, but they also have an overlap. If we add in a third clause, now we can see that there's three clauses and three overlaps and one super overlap. So like overlap squared, overlap prime, however you want to say that out. And if we draw it out, this is a two-dimensional Venn diagram, so there's a limit to how many circles we can put in. It's either 3 or 4. But if we draw it out, we can see that the total number of shapes overlaps, there are overlaps. For x shapes, we have 2 to the power of x minus 1 overlaps. So we can see 1 was 1, 2 was 3, 3 is 7. So as we can see, it increases exponentially. Which means that it's an exponential time and actually exponential space algorithm, and so it doesn't work. Specifically, let's just go into it real quick. The way you would implement it is, let's say you have the shape is ABC, since that the clause was not A, not B, not C. And then you have another clause, DEF, or not D, not E, not F. So the second area would be DEF. Well, ABC means that ABC and any other combination of values after it would be invalidated. DEF means any combination of values after it would be invalidated. So if we, let's just write ABC, and then I'll write DEF here, so we can see that DEF, just to keep them in line, we have any values after DEF and ABC before it, or not A, not B, not C, any possible combination. We can see that the overlap of these two would be ABC, DEF. So that would be this overlap here, assuming this is ABC, this is DEF, this is ABC, DEF. Similarly, if we have ABC and then CDE, we can see that they already share one value, so the overlap would be ABDE or ABCDE. So here the overlap is 2 to the I minus 6 because there's 6 values that are required, and then the overlap is any other combination. Here we can see the overlap is 2 to the power of 5 because they share I minus 5 because they already share C, so they're already much more similar than two random clauses, which means that they have a much larger overlap of I to the minus 5 instead of 2 to the power of I minus 6, which would of course be smaller. And last but not least, if it's ABC and then AB not C, DE, then we can see that they have no overlap because there's no possible values here that would give any overlap with any possible values here since it's C and not C. They're like on two separate sides of the hypercube and they cannot overlap. So that's how you would do it, but of course, as we showed, it takes exponential time or exponential space, and so the solution doesn't work. So that was a relatively quick one, at least in terms of theory. I just showed it like 3 different ways. Tune in again for the next ones, I guess, and thanks for listening.